I was stuck in traffic the other day.
Oh, the best place for deep thoughts.
Yeah, right. Just staring at the bumper in front of me. And I started looking at the strip mall to my right.
Let me guess. A gas station, a nail salon.
Exactly. A fast food burger joint and a pharmacy. And I had this weird moment of deja vu. I realized I could be in Ohio or Florida or California, and that exact same cluster of businesses would be right there.
Yeah, it's like a copy-paste landscape. The absolute hallmark of modern suburbia. It feels entirely inevitable, doesn't
It
it?
really does. But then, fast forward to the weekend, I wanted to go see a specific touring band, and suddenly I'm not just driving 5 minutes down the road. I'm planning this whole 3-hour expedition into the heart of the major metro area.
Paying $50 for parking.
Oh, easily.
Yeah.
Dealing with the chaos and crowds. And it just made me wonder, why is it that I can get a gallon of milk within walking distance of my house, but for certain things I have to go on an actual pilgrimage?
Well, it's the kind of thing most people just accept as the way it is. I mean, we assume cities just sort of happen, like maybe a river was there or a railroad stopped there and the rest was just random organic growth.
Right, like tossing seeds in a garden and just seeing what sprouts.
But that's the illusion. The reality is actually much more rigid. If you look at the research we're getting into today, specifically the principles of urban hierarchy and spatial distribution, you realize that none of this is random at all.
Not even a little bit.
No, there is a hidden math at work here. A very specific set of invisible laws that dictate exactly where a gas station can survive versus where a neurosurgeon can set up shop.
And that is exactly the promise of today's deep dive. We're going to give you the listener X-ray vision for the next time you look at a map. We aren't just looking at dots on a page anymore. We're looking at physics, geometry, and some surprisingly elegant formulas.
We really are. We've got 4 big frameworks from the source material to unpack today.
Yeah, let's lay them out.
So first we're going to talk about the urban hierarchy, which is basically the pecking order of cities. Then we'll look at the battle between the rank size rule and the primate city. We'll cover the gravity model.
Which involves actual gravity?
Yes, actual gravity.
Yeah.
And finally, my personal favorite central place theory, which literally turns the world into a board game of hexagons.
Hexagons. We will definitely get to the hexagons. But let's start with that pecking order. The urban hierarchy. To me, as I was reading this, it just sounded like a corporate org chart.
That's a great way to put it.
Right. You've got the CEO, the VPs, the managers, and the interns.
It's a fantastic analogy. The source refers to this as a ranking of settlements based on their size and, more importantly, their function. At the very top, at CEO level, you have what geographers call S-tier, or high-level cities.
Now, S-tier sounds like a ranking in a video game. But in the real world, what actually makes a city S-tier? Is it just having a massive amount of people?
Well, population is definitely a part of it, but function is the real driver here. S-tier cities provide high-order functions that you literally cannot find anywhere else.
Like what?
Think about major corporate headquarters, international stock exchanges, specialized research universities, or going back to your medical example, those pediatric neurosurgeons.
And so it all comes down to scarcity.
Exactly. Highly specialized services require a massive population to support them. You can't put a stock exchange in a town of 4,000 people.
Right. No one would use it.
It would be functionally useless. So these S-tier cities essentially hold the highest concentration of power, influence, and specialized services.
Okay, so that's your CEO. Then you slide down the ladder to the VPs and the managers.
Right. As you move down the hierarchy to medium cities, small towns, and eventually villages, the functions become less specialized and much more generalized.
So you lose the opera house, but you keep the movie theater.
Exactly. You lose the specialized research hospital, but you keep the urgent care clinic.
Until you get to the very bottom, the intern level, which is just the hamlet. And there you basically just have a gas station and maybe a post office.
Precisely. But here is the key insight that the notes really emphasize. These tiers do not exist in isolation.
They're connected.
Yes, they are locked in a relationship. This is what geographers call the city situation.
City situation. It sounds like a reality TV show.
It does, but it's actually the functional connection between cities. Think of it like a biological system.
Okay.
The heart, the lungs, the brain, they all do completely different things, but they absolutely rely on each other to keep the body alive. Cities are the exact same way. One city might be the manufacturing hub, the muscle. Another is the port, the mouth. Another is the banking center, the brain.
So if the manufacturing hub shuts down, the banking center eventually starves. They aren't independent islands.
Exactly. They're nodes in a network. And understanding that interdependence is crucial to understanding why your local town looks the way it does, almost certainly serving a specific role for a larger city nearby.
Okay, so we've established that cities are ranked and they're connected. But here is where I want to push back on the whole hidden math idea. Can we really predict how big these cities get? Because human behavior is messy. We move for love, for weather, for better jobs. It just feels entirely chaotic.
It definitely feels chaotic on the individual level, I'll give you that. But when you zoom out to the macro level, the data gets scarily consistent. And this brings us to the two competing models of city size, the rank size rule and the primate city rule.
Two rules that basically describe two very different kinds of worlds. Let's start with the rank size rule, because honestly, when I saw the formula for this, I thought it was a joke. It's just way too clean.
It is incredibly elegant. It's known as the 1/n rule.
Walk us through that in plain English.
It states that the nth largest city in a country will be 1/n the size of the largest city.
Okay, I'm going to be the skeptic here. Let's use some real numbers. If our biggest city, let's just call it Metropolis, has 10 million people.
Then the second largest city, where n equals 2, should have exactly half that population, so 5 million.
And the third largest?
1/3. So roughly 3.3 million. The fourth largest is 2.5 million. And so all the way down the line.
Does that actually happen in reality, though?
Yeah.
Or is this just something economists put in textbooks to make themselves feel better about a chaotic world?
It absolutely happens. The source material points to the United States as a prime example of this. Look at New York City. The population is roughly 8.6 million.
Okay.
Now it's the second largest city.
Los Angeles.
Right. And its population is around 4 million, almost exactly half.
That is just weird.
It gets better. The third largest is Chicago, around 2.7 million, which is roughly a third.
It's spooky that it lines up that perfectly.
But why? Is there some government official making sure Chicago doesn't get too big? Like, sorry, folks, we're at capacity. You have to move to Houston.
No, it's entirely organic. It signals a balanced urban system. The rank size rule typically appears in developed nations with a federal history or a decentralized economy. It means that wealth opportunity and infrastructure are actually spread out. So you don't have to live in New York to make it. You can go to Chicago or Houston or Phoenix and still find a really high tier of services.
Exactly. There are multiple engines driving the car. But, and this is a big but, that is not the case everywhere.
Right. Enter the dominant model, the primate city, which, by the way, is a great name. It sounds like the king of the jungle.
And it absolutely behaves like one. A primate city is defined as a leading city that is disproportionately large. Usually we're talking more than twice the size of the next largest city.
Wow.
And it completely dominates the country's economy, its politics, and its culture.
So the clean math we just talked about totally breaks down here.
Completely shatters. The classic example in the text is Mexico City.
Right. Looking at the data here, Mexico City has around 20 million people. The next largest, which is Guadalajara, has about 5 million.
Right. So if it followed the rank size rule, Guadalajara should have 10 million, but it's only half that. Mexico City isn't just double the size, it's 4 times the size.
We see this in Europe too, don't we? London and Paris are massive compared to Manchester or Marseille. But here's my genuine question. Is that bad? Because if I'm living in Paris, I'm loving it. I have everything I could ever need right there.
For the residents of the primate city, it can be fantastic, although obviously expensive and very congested. But for the country as a whole, it often signals uneven development.
It's a resource vacuum.
Precisely. It acts like a black hole. It sucks in all the investment, the infrastructure, the young talent. If you are living in the periphery, far away from the primate city, you are often left with just the scraps.
The source notes mention that this is often a legacy of colonialism. Can you connect those dots for us? Why does being a former colony lead to having one giant city?
Think about the goals of a colonizing power. They aren't there to build a broad, interconnected, balanced economy for the locals. They're there to extract resources and ship them back home.
Right. Get the timber, get the minerals, and get out.
Exactly. So they pick one spot, usually a port or a central administrative hub. They build all the railroads to lead straight to that spot. They put the government there. They put the banks there.
So everything just funnels to one single point.
Yes. And even after the colonizers leave, that infrastructure remains. The momentum is already established. Everyone moves to the capital because that's where the rails go. That's where the jobs are. It creates this immense feedback loop that is very hard to break.
So when you look at a map and you see one giant blob and a bunch of tiny specks,
Yeah.
you're often looking at history. You're seeing the ghost of how that country was organized 100 years ago.
That's a great way to say it. Geography is just history written in stone, or in this case, concrete.
Fascinating. Okay, so we've looked at the hierarchy
Mm.
and the size rules. Now I want to shift to the invisible forces that pull these cities together. I want to talk about the gravity model.
Ah, yes. Pure physics envy. Geographers looked at Isaac Newton and said, hey, we can use that.
It makes sense, though. Newton said gravity is determined by mass and distance. The bigger the object, the stronger the pull. The closer the object, the stronger the pull.
And in urban geography, we just swap the variables. Mass simply becomes population size. And distance, well, that stays distance.
So the theory is that the interaction between two cities, meaning how much they trade, how many phone calls, how many flights, is predictable based on just those two numbers.
Right. Let's look at the distance factor first because it's the most intuitive. We call this the friction of distance.
Which is really just a fancy way of saying it's a hassle to go far.
Pretty much. Interaction is incredibly high between New York City and New Jersey. Why?
Because they're right next to each other. You can just drive across a bridge. People commute every single day.
The friction is low. But here is where the mass factor comes in and completely overrides the distance. Take New York and Los Angeles.
Opposite sides of the continent, 3,000 miles apart. By the logic of distance, they should barely even talk to each other.
But they have massive interaction. Why is that?
Because they're huge.
Yes. Their mass is so great, the sheer number of people, the amount of money, the cultural industries, that they create a gravitational pull that literally warps the space between them.
I love that image. It's like they're wormholing through the country.
In a way, they really are. A flight from JFK to LAX is that wormhole. The connection is strong because the gravity of the opportunity is strong.
So if I'm a small town in Kansas,
You might be physically closer to LA than New York is, but you don't have the mass. You're a tiny asteroid. You just don't have the gravity to pull the spaceship off course.
this is actually really useful for understanding things like migration, isn't it?
Mhm.
If you're trying to predict where people will move, you don't just look at what's close, you look at what's big.
Absolutely. Big cities have a sticky quality. Once people get there, the gravity keeps them there and it pulls even more people in. It explains why mega cities tend to keep growing despite the terrible traffic and the insane cost of living. The gravity is just too strong to escape.
Okay, speaking of patterns on a map, we've done the physics. Now I want to get into the geometry. I want everyone listening to visualize a map, but instead of the messy squiggles of borders and rivers, I want you to imagine it covered in perfect hexagons, like a giant beehive.
We have finally arrived at central place theory. Walter Kristaller, 1933.
This is probably the most sci-fi sounding part of the reading, but at its core, it's really just about shopping, isn't it?
It is. It's a model to explain how settlements are spaced out. Kristaller noticed that towns aren't just randomly scattered around. They actually follow a pattern based on providing goods and services.
And he used two key concepts to explain this: threshold and range. These are essentially the economic laws of the land.
Let's break them down. First threshold. This is the absolute minimum number of people needed to support a business.
So let's go back to my bumper-to-bumper traffic epiphany. A coffee shop.
Very low threshold. You need, what, maybe a few hundred regular customers to keep the lights on?
But you find them everywhere.
Everywhere. Small towns, villages, city corners. Now take a professional sports stadium.
Massive threshold. You need tens of thousands of people just to fill the seats, let alone buy the jerseys and watch the ads on TV.
Exactly. You cannot put an NFL stadium in a hamlet. The business model collapses immediately. The population base, the threshold, just isn't there.
Okay, so that's the business side of the equation. Now the consumer side. Range.
Range is the maximum distance a person is willing to travel for a specific good.
I call this the how bad do I really want it factor.
That's spot on. For a low-order good like a loaf of bread or a gallon of gas, your range is very short. You are not going to drive an hour for gas unless you absolutely have to.
No way. I'm going to the closest one even if it's a few cents more.
But for a high-order good, say, specialized cancer treatment or maybe a very specific vintage luxury car,
Your range completely expands. You will bypass all the small towns, drive for hours, maybe even fly across the country to get to the source.
so when you combine these two things, the business needing people, which is threshold, and the people needing to travel, which is range, you get this fascinating nesting doll effect.
Right. You get lots of small places offering low-order goods and fewer big places offering high-order goods. And Kristaller realized that if you map this out on a flat surface, the most efficient shape for these market areas isn't a circle. Why not a circle, though? Circles seem so easy and natural.
Circles are actually messy. If you pack circles together, you either have gaps between them where no one is being served, or you squish them together and have overlaps where businesses are just cannibalizing each other.
And squares.
Squares are okay,
Yeah.
but the distance from the center to the corner is much farther than the center to the edge. It's not a consistent range.
So the hexagon.
The hexagon is perfect. It fits together like a puzzle, no gaps, no overlaps, and it closely approximates a circle. So in Christopher's model, the world is a honeycomb. You have the big central city, the queen bee, surrounded by medium cities, which are surrounded by smaller towns.
It's incredibly satisfying logic.
Mm.
But I have to point out the obvious here. I look at a map of the US or Europe, and I certainly do not see perfect hexagons.
No, you see total chaos.
So is Christaller just wrong?
He wasn't wrong, but he was simplifying. He assumed an isotropic plane, a perfectly flat, featureless world with perfectly even population distribution.
Which is definitely not Earth.
Right. We have mountains that block travel, we have rivers that funnel trade, we have deserts, and we have politics.
Politics is a huge one. The notes explicitly mention that some cities exist for non-economic reasons.
Just look at Washington, D.C., or Brasilia in Brazil, or Canberra in Australia.
These aren't cities that grew organically because of a market threshold.
No, they were placed there by a government decree. They said, we will build a capital exactly here. They break the hexagon model entirely because they exist for administration, not primarily for commerce. So yes, the real world distorts the hexagons, but the underlying logic threshold and range is still very much in effect.
Or it was, until we broke the biggest variable of all.
Technology?
This is the part of the deep dive where we really have to ask, are these rules dead? Because Christaller was writing in the 1930s. He did not have Amazon Prime.
This is the modern disruptor. The source material ends by looking at exactly how technology challenges these geographic assumptions. And it primarily attacks that concept of range.
Well, first it was the car.
Right, the car stretched the range. Suddenly driving 20 miles to a Walmart wasn't a big deal, and this killed off a lot of those tiny low-order hamlets because people could just bypass them to get cheaper goods at the much bigger store.
But the internet doesn't just stretch the range, it deletes it.
It theoretically reduces the friction of distance to absolute zero.
Think about it. We defined range as how far I'm willing to travel. If I can order a highly specialized electronic component, a high-order good, for my couch, my travel distance is zero, I don't need to be near the S-tier city anymore.
It creates what some geographers refer to as the death of distance. You can theoretically live in a cabin in the woods and access the exact same global market as someone living in downtown Manhattan.
And it's not just shopping, it's work too. The whole Zoomtown phenomenon. If I can be a high-powered attorney or a senior tech developer from a mountain town in Idaho, do I really need the S-tier city?
This is the billion-dollar question right now. If central place theory is based entirely on physical proximity and we suddenly remove the need for proximity, do the hexagons just dissolve?
It feels like they should. We should all just spread out evenly like butter on toast.
And yet, if you look at the data, are cities actually emptying out?
No. They're getting more expensive. People are still fighting tooth and nail to get in.
So clearly the internet hasn't killed the city. Why do you think that is?
I guess we still just like people.
It's the gravity again. But it's not just economic gravity anymore, it's social gravity. Agglomeration. We deeply crave the collision of ideas, the serendipity of running into someone, or the dating pool, the culture.
You definitely can't get that on a Zoom call.
You really can't. The internet is phenomenal for transactions, but it's terrible for real connection. So even though we theoretically can live anywhere, we still actively choose to cluster. The S-tier cities are becoming less about hardware-like factories and ports, and much more about software, human connection, and innovation.
That is a really hopeful way to look at it, actually. The city isn't dead. It's just evolving from a marketplace of physical goods to a marketplace of experiences.
Exactly. The reasons for the hierarchy are shifting, but the hierarchy itself remains solid.
So let's quickly recap the map we've drawn today. We started with the urban hierarchy. The idea that cities are ranked strictly by function, with those S-tier CEOs at the top holding the specialized keys to the kingdom.
Then we saw how that ranking plays out in the real world with the rank size rule, that incredibly satisfying one over on stair-step of a balanced system.
Versus the primate city, where one giant hub dominates the entire landscape, often echoing a colonial past.
We looked at the gravity model, visualizing those invisible rubber bands of mass and proximity that bind New York to LA, completely defying the physical distance between them.
And finally, we walked through the hexagons of central place theory. Understanding how the threshold of a business and the range of a customer created the literal blueprint for our towns.
And how the internet is currently trying its hardest to rewrite that blueprint.
It really changes your perspective on a simple commute. You realize that you aren't just driving to the store, you are an active data point in a massive living algorithm. Every time you drive past the local shop to go to the big box store, you are validating the math.
You are actively expanding your range and reshaping the hierarchy.
So here is a final provocative thought to leave you with, and it's a bit of a brain melter. We talked about how the internet lets us access high-order goods from anywhere. If that trend continues, are we seeing the end of the traditional physical primate city? Or is the internet itself becoming the ultimate primate city?
Oh, that is a fascinating thought. A total digital centralization.
Think about it. We might be physically scattered, living out in our little separate hexagons, but digitally we are all crowded into the exact same 3 or 4 massive platforms. We all shop at the same everything store.
The hexagons haven't disappeared, they've just uploaded to the cloud.
And the gravity there is stronger than anything Newton could have ever calculated. Something to mull over the next time you click Buy Now and just wait for the truck to bridge the distance. Thank you for joining us on this deep dive into the hidden rules of our cities. We will see you next time.